Welcome, math apps. We are on day 9 of section 2.3. We're going to talk about linear functions. So first thing we want to review is slope. So slope formula here is y2 minus y1 over x2 minus x1. It's the rise over the run. So your change in y over the change in x. A few very common slopes that we should know are a vertical line. For a vertical line, the slope is undefined. Now, how I remember that is vertical is up and down, and I think of a little person walking or on a bike or something, and they're saying like, because they're falling down. They're undefined of their future. Kind of cheesy, but hey, it might help you remember. Versus a horizontal line, the slope is 0. How I remember that is horizon, so that's a horizontal line. Think of a person walking on there. Well, this person has 0 worries. They're just walking along. Nothing's worrying them. They're fine. So those are 2 very common slopes that people forget, so maybe this cheesy way will help you remember it. Now we're going to do example 1, which is find the slope of a line passing through those 2 points, P1 and P2. You can feel free to label x1, y1, x2, y2, and then we plug into the formula above, right here. So the slope would be -2 minus 4, 1 minus -3, so you add 3, be -6 over 4. Always simplify if you can to -3 over 2. So if I graphed those 2 lines, the difference would go down 3 to the right 1, down 3 to the right 2. Now find for your other points. It does not matter which one you call x1 or y1, as long as they're together. So this point is x1, y1. This can be x2, y2. Whoa, that's weird. y2. It doesn't matter as long as they are together. Again, plugging into the formula above, we would get -10 minus 7, 3 minus 3. -17 over 0. You cannot divide by 0. It will give an error on the calculator, and it's not something that you can algebraically do. So in this case, the slope is undefined. If I were to graph it, you would see it would be a vertical line like right here, because they have the same x value. This one goes down 10, and this one is up 7. So it would be that vertical line, slope would be undefined. Here are a couple forms of lines. So we have slope-intercept. It's called slope-intercept because you're given the slope, and the b value is that y-intercept. Standard form is ax plus by equals c. This form really tells us not much. What it tells us is that we can use our x and y intercepts and graph from there, but not much for linear lines. The other one is point slope. Y minus y1 equals slope x minus x1. In here, just to remind you, the point is x1, y1. Here, the y-intercept would be 0, b. For a vertical line, let's go back up here. Vertical line is going up and down. So all we know is that they have the same x value. So x equals. Y is horizontal, so that y value would be that number. So let's try a couple. We're going to graph each line in the appropriate form. Make sure to list and plot exact points. Okay, couple things to do here. First is this form is slope-intercept. I know that because it's in the form of y equals mx plus b. That means my slope is -3. Oops, I'm so sorry. And my starting point is 0, 2. So I go up to 0, 2 and a slope of -3. So down 3 over 1. Down 3 over 1. You can keep the pattern going on the other side. Up 3 over 1. Up 3 over 1. This would be that line. Now we also want to graph a few points. So we might as well put our XY table in here. One of the points is 0, 2. This point right here is 1, negative 1. This point over here is negative 1, up 1, 2, 3, 4, 5. So just a few. And we also could find this by just plugging in the x value here, kind of our function notation, and come out with 5. Question B is in standard form, this form right here. Like I said, it doesn't tell us much, but it does tell us our x and y intercepts. So looking here, if I plug 0 in for x, this term goes away. I'm left with negative 3y equals 6, so y would be negative 2. If I find the that was y-intercept. If I find the x-intercept, then this value 0, it goes away. And I'm left with 2x equals 6, so x would be 3. So graph 0 down 2, 3, 0, and that would be your line. You also could solve for y equals mx plus b, and graph from there as well. Your method does not matter to us. You can choose. A couple more examples here. See, this is in point slope. So the point is negative 4, 1. It's the opposite of both of those values. And then my slope is negative 3 over 2. So if I go to the point 1, 2, 3, 4 to the left, up 1, and complete my slope down 3, 1, 2, 3 over 2, 1, 2, 3 over 2. I could keep going up. Here would be my line. A couple points to go with that just to confirm our shape. We have negative 4, 1. This point here is 1, 2, 3, 4, 5. Yep. So x is 0, negative 5. And this point over here, 1, 2, 3, 4, 5, 6, negative 6. Negative 6, 4. So just make sure we know what your points are trying to read. Y equals 5. Well, okay, this is y equals. So if I think about y equals, that should be a horizontal line because I know the y value. Well, y equals 5, 1, 2, 3, 4, 5, would be this horizontal line right here. A couple points that are on it would be anything with a y value of 5. 0, 5, 1, 5, negative 1, 5. All of them have the same y value, hence the equation y equals 5. The last thing we're going to talk about is parallel and perpendicular. Parallel means the same slope. Notation for that is usually 2 diagonal lines. Perpendicular have opposite reciprocal, and that's noted by an upside down capital T. Opposite reciprocal means you flip the numerator and denominator and flip your sign. So a quick example here, if I had the slope to be 3 over 4, the perpendicular slope would be the opposite, so now it's negative, and you change the top and bottom, numerator and denominator flip. So let's try a couple. Find the equation on the line that satisfies the following condition. I have a slope and a point. Now this is a very special point. This is the y-intercept. So I'm going to plug in to slope-intercept because I'm given the slope and the y-intercept. Y equals mx plus b. Vertical line, I know from above, vertical line just cares about the x. And my x in this case is negative 2. Now, for C, it passes through these 2 points. In order to write an equation on a line, I for sure need a slope. So that's where I'm going to start. Using my knowledge of slope, I'm going to plug in to y2 minus y1, x2 minus x1, and get 5 over negative 4. And then I can choose either point to plug into. It does not matter. If I plug into the first point, or the second point. And you can leave your answer just like that. It might ask you to simplify into slope-intercept. In that case, we're going to distribute and get y by itself. But for now, I'll just leave it like this. And we'll try our next one. Part D says parallel to this line and passes through a point. Well, okay, I'm given a point, so that's good, but I need to find a slope. So using this is in standard form. I'm going to change that into slope-intercept. So I'm taking this, changing it into something I can read. To find my slope. So y is going to equal 2 over 3x minus 7 over 3. I'm doing this to find my slope, my m value. Well, the slope here is 2 over 3. Since it wants parallel, I'm going to write my diagonal lines, parallel slope is still going to be 2/3. It's going to be the same. I'm going to take this slope with this point and plug in to point slope. Y plus 2 equals 2/3 x plus 6. Now this one I will convert into y equals mx plus b just to show you. So to convert, you would distribute. So y plus 2 is going to equal 2 over 3x. 2/3 times 6. Well, 6 divided by 3 is 2. 2 times 2 is plus 4. Subtract 2 from both sides. This would be an equivalent form. Here and here are equal. It just depends on what form you want your final answer in. The first one is point slope, and this one's slope-intercept. It would be the same line. The only thing different now for E is that I want perpendicular. First one said parallel. This one says perpendicular. So let's do the same exact steps, which if you notice, this equation is the exact same here. So all this work, I can just copy on over because it's the same problem. But this time, I want perpendicular. Like we said in our example, the perpendicular, you switch the top and bottom, and it becomes negative. So take that slope, this point, y plus 2, negative 3/2, x plus 6. And there is your day 9 notes. If you have any questions about lines or graphing, please make sure to ask in class. See you later.